Hi guys, welcome back to my mathematics tutorial. I'm Peter C. Dogba Jr., your math tutor, and in this lecture, we want to continue with variable separable, solving the fourth problem. So in the previous lectures, we did question 1 to question 3. So we want to solve the fourth problem. Now the problem says that secant squared of x tangent of y dx plus secant squared y tangent of x dx. So we told you when you have the chance of separating the terms with x and the terms with y, then it means that you can apply the method of variable separable, right? If that cannot work, then it means that you have to apply other methods. So let's look there now. And we have this first term. So we rewrite this first term right here, right? Or since we want to make this dy to be kind of, the term on the left hand side, we can write the dy first. So we have secant square y tangent of x dy equals, then we send this one across and it becomes minus secant square x tangent of y dx. So now what we need to do is that we need y, all of the expressions that is like a factor to this dy should be in y. So this is secant square y is okay, but we don't need this tangent of x. So we divide both sides by tangent of x. Likewise, we do not need tangent of y on the side, so we divide both sides by tangent of y and tangent of y. So this tangent of x cancel this tangent of x, you have secant square y dy all over tangent of y, all equals minus. So this tangent of y can cancel. Okay, this is tangent of y, sorry. So this tangent of y can cancel this tangent of y. You'll be left with negative secant square x all over tangent of x. So now we can integrate both sides. Now since all of the expression or let's say the expressions here are all in y and the expressions here are all in x. So this is the x. We can now integrate both sides to find the general solution. So look here. We know that if we say let u equals to tangent of y, the derivative of tangent of y is equal to secant square y. So we can say let u equals to tangent of y. So if we differentiate both sides, the derivative of u is du. The derivative of tangent of y is just secant square of y dy. So whenever we see secant square y dy, we want to write du, and wheresoever we see tangent of y, we want to write u. So this is the integral of this whole thing is just du, and down here is just equal to u equals minus. So remember that we can do the same thing on this side. We say let v equals to tangent of x, and then dv now equals to secant square x dx, right? So now we will have the integral of, so this is just dv, and then down here now is v. So the integral of the u all over u is equal to the ln of u, and the integral of dv all over v is equals the ln of v plus c. So now we are to, remember we are to solve for y, because y is the name of the function, and we need to solve for y. So basically we have to bring back the value of u and v. So we have u to be equal to tangent of y. So this is the ln of tangent of y equals negative, the ln of v now is tangent of x plus some arbitrary constant c. So it will be like very difficult for us to easily solve for y. So we can just simplify the expression. We can solve for y as well. So we can just simplify the expressions. Now we have ln of tangent of y. Now we send this term across, it becomes plus tangent ln tangent of x plus some arbitrary constants. So we just say equal to, can I write plus equal to 0? So now we told you when you have the ln of A plus the ln of B is just equal to the ln of A times B. So this now will be the ln of A times B, which is just tangent of y and x. So I'll put tangent of x first and tangent of y plus some arbitrary constant c equals to 0. So you see that? So in order for us to like combine all of these expressions, I could rewrite this c as the ln of e, because I know that the ln of e is just equal to, or I could say the ln of c. The ln of c is still a constant, and you know the ln of c is a constant. So I could say the ln of c, and I could even say the ln of e is still a constant, right? So you could say the ln of c, and then you combine the two of them now, which would just be ln of c tangent of x tangent of y plus, let's say, equal to 0. So I just rewrite this c as ln of c. But mind you, you can stop here, you can stop here, you can stop your answer right here. You can even stop your answer. You can avoid rewriting it as c. You can just say plus c, whatever the case might be, it's still your answer. So thanks ever so much for watching. Please subscribe to our YouTube channel so we can always have fun, because mathematics is fun. Thanks ever so much. See you in our next lecture.